Okay, so let's learn how to now do two-step conversions, which we have learned before last semester, but now we're going to do them with compounds. So here we go. It says how many molecules of barium sulfite are in 451 grams of barium sulfite. So let's label everything. This is what we want. This is what we're looking for. So what do we have? We have 451 grams. This is what we have. Okay, so you are going from grams to molecules. Well, the first thing you write down is always what you have. So whatever number you got, that's the first thing that should go here, 451 grams of barium sulfite. Now let's think, you're trying to go from grams to molecules. And so let's look at our mole map here to determine how many steps it takes to get there. This right here is what we have. Molecules over here is what we want, right? So just like train stops, okay, we can't just like, a train can't jump over a train stop to get to the next one. So for us, we have to go and make a stop at moles, convert to moles first, and then we're going to go over here and convert to molecules, because molecules is what we want to end up with, right? So it takes two steps and it takes two conversion fractions to get there. So we're going to draw two conversion fractions so we get to the final answer. This is what we have. We don't want grams, so we got to get rid of it, and it goes on the bottom of the fraction. Then what is the next stop? Once again, what's right next door? You have to make a pit stop at moles. So we're going to make a pit stop at moles here. Now, is moles our actual destination? No, right? We don't want moles, and so we have to get rid of it by putting it on the bottom. We always put what we don't want on the bottom. What you want has to always end up on top of the fraction, has to triumph in the end. Okay, so what are we looking for here? We're looking for molecules at the very end, like this. Now, anytime you have a fraction of any kind, did you write a fraction, right? Do you see any of these words in a fraction? Then you have to use these numbers, okay? So here we have a fraction. This is a fraction. Then you have to find the matching word to the matching number. So here, what word mole is the matching number, right? So you see the word mole over here, then what's the matching number? 1. So you put a 1 in the fraction down here. Then, right, what's the number that goes here in grams? It tells us that we have to get this number from the periodic table. It's the mass of the entire compound. So what is the compound? The compound is barium sulfite, right? So we have to find barium sulfite, in our periodic table. So we have to take 1 barium, 1 sulfur, and 3 oxygens and add them all up together. So let's find our barium, right? Sulfur is already highlighted, and oxygen. So let's go ahead and add those up. So barium is 137.33. So 137.33. We're going to add 1 sulfur, which is 32.06. And then we are going to add 3 oxygen. So 3 times 16 is going to give us 217. I already forgot the number, 39 grams. So this is the mass of the entire compound. So once again, we have a fraction. So in this fraction, then we write the matching word with the matching numbers. So find the word mole. What's the matching number? 1. And then you do the same thing for the word molecule. The molecule here, right, is the words here. So what is the matching number? The matching number in blue is Avogadro's number. So it's 602 sectillion, 6.02 times 10 to the 23. So 6.02, I'm going to do E23 like this. Now every slot is filled up. So now all we have to do is calculate it. You take 451 and you multiply by the top number. You then divide by the bottom number, 217.39. Then you multiply by the top number, 6.02, exponent of 23, You divide by 1. You don't have to write it or not, but you should get an answer of 1.25. Okay, so 1.25, and then a lot of people put molecules of barium sulfite. Now, some of you are like, but wait, you're right, but wait, look at the calculator. Did you forget about the E24? There's an exponent. So you can't forget it, E24, right? So E24, right? If you were to properly write this on your notes, you would write times 10 to the 24th power. You cannot forget exponents. That's how you get half the answer incorrect, okay? So now let's try one more. We're just gonna go backwards. In this problem, you are given, right, 9.1 times 10 to the 23 molecules. This is what you have. You're always given a single number here. So that's the first thing that you need to write down. It wants to know what is the mass of your sample. So it wants to know, right, this is what you want. You want grams instead. So let's follow the same process. You have 9.1, okay, times 10 to the 23rd. You can write E23rd if you would like. And this is molecules. And then you got to think, I have to go from molecules to what? Grams. So you look over here and you're like, okay, the word molecules is here. The word grams is over here. I can't skip. So I have to make a pit stop at moles before I convert to grams. So it still takes me 2 train stops to get to the answer. So I need to write 2 conversion fractions, because that's how many times it takes to convert my answer. Molecules is not what I want. So where do I put this? On the bottom of the fraction to get rid of it. Then what is my next stop? Your next stop is always moles. It's your pit stop. That's not your final answer. But moles is where I am going to make a stop. Right? I don't actually want moles, so you know it goes on the bottom here, right? What is my destination? What you want has to always end up at the very end, at the very top. You wrote that you want grams, okay? So you're making a lot of side notes to yourself. Now you have 2 fractions here. So I want you to just pause maybe and try to see if you can fill it out yourself, and then check to see if we put the matching numbers there. Okay, so did you put the correct numbers? So you're trying to get rid of molecules. So you find the matching word with the matching number, right? Matching word, matching number. Molecules is always Avogadro's number. Moles is always 1. Grams you had to get from the periodic table. So here you had to take Na and NO3 and add them all up. So the question is, did you take sodium, this 22.99, this 14.01, and 3 oxygens, add them all up together to get 85, and then we calculate it. Okay, so let's calculate it all together. 9.1 e to the 23 power. You multiply by the top. The line tells you to divide by the bottom number. Remember, you're using your exponent. You multiply the top, you divide by the bottom, and you should get this cool answer of 128.49. 128.49. What did you want? What did you want to end up with? Grams of what substance? Sodium nitrate. So that is how you get your final answer. Now, at this point, it's your goal to then figure out how many steps it takes to get to the answer. Sometimes it's only 1 step. Sometimes it's 2. So it's your job to figure out, using your mole map, how many steps does it actually take to get to your answer? How many conversions does it take? Now down here, you can just totally ignore this. We're just going to skip this part, so don't worry about it. We'll practice in class, so good luck.